Hello students, welcome. Previously, lesson 11 from 4 to big 4, we were dealing with electrolysis and we have seen two types of electrolytes. The first one was binary electrolytes, and we said these are electrolytes that when decomposed produces only two ions. For example, we can talk about molten sodium chloride. When you're having molten sodium chloride, the ionic compound, that's the ionic sodium chloride, dissociates to produce sodium ion and also chloride ions as the only ions. So that means we are having only two ions, and specifically it is one type of cation and also one type of an ion. So the cations will be moving towards the cathode because they are positively charged cations, then they will be getting attracted towards the negative terminal of the battery, that's the cathode. Then chloride ions, being negatively charged and ions, they will be getting attracted towards the anode because the anode is the electrode which is connected to the positive terminal of the battery. So during electrolysis, that means sodium ions will be discharged at the cathode and chloride ions will be discharged at the anode. That's what they have said. So next type, or the second type of electrolyte, is known as non-binary electrolytes, and a good example of non-binary electrolytes were aqueous solutions of ionic substances. For example, we can talk about aqueous solution of sodium chloride. Aqueous solution of sodium chloride. So in the aqueous solution of sodium chloride, it contains the ionic compound, that's sodium chloride, being decomposed to produce sodium ion and also chloride ions. And also water in the solution, we are told, also ionizes or undergoes chemical decomposition to produce hydrogen ions and also hydroxide ions. So in total, when we're talking about aqueous solution of sodium chloride, it consists of more than two ions. That's why we have said non-binary electrolytes are electrolytes when the compost produces more than two ions. So here we're having four ions in total. So two of them are positively charged cations and two of them are negatively charged anions. So that means the positively charged cations, that's sodium ions and hydrogen ions, migrates or moves towards the cathode, because cathode is the electrode which is connected to the negative terminal. Then the negatively charged chloride and also hydroxide and ions, they will be getting attracted towards the anode because the anode is the electrode which is connected to the positive terminal. But we are told one of the ions will be discharged at each electrode, and this is known as the preferential discharge of ions during electrolysis. That is what we are going to do in our class today. Kindly stay with us until the end of the video. So I said the factors affecting the preferential discharge of ions during electrolysis, they are three major factors that determines the products of electrolysis. These factors are, number one, the position of the cations and anions in the electrochemical series. Number two, the concentration of ions in the electrolyte. And number three, the nature of electrode used. And I said each of these factors will be discussed in details. So we're going to proceed to the first factor, that's the position of cations and anions in the electrochemical series. We are saying the ease of oxidation of anions and reduction of cations depends on their position in the electrochemical series. For example, we said we are having cations. Cations are positively charged ions. They will be getting attracted towards the cathode. When we're talking about cathode is the electrode where reduction occurs. You have to know that. Reduction occurs. Then we are having anions. Anions, they are negatively charged ions. They will be getting attracted towards the positive terminal of the battery. That's the anode. An anode is the electrode where oxidation occurs. So that means when we're talking about, or when we're explaining this point, remember we're told the ease of oxidation of anions. When we're talking about anions, we are talking about oxidation, obviously, and reduction of cations. When we're talking about cations, what we're talking about is reduction of cations. depends on their position in the electrochemical series. And we are saying the anions high in the series, that high in the electrochemical series, requires more energy to be oxidized. So because we are talking about anions, we are talking about oxidation, obviously. And the cations high in the series, that means high in the electrochemical series, requires more energy to be reduced. We are talking about cations, therefore we talk about reduction. So we are told they require more energy to be reduced. So that means the anions which are the bottom of the electrochemical series are the ones that will be preferentially discharged, and the cations that are at the bottom of the electrochemical series are the ones to be discharged at the cathode. Then they are the ones to be getting reduced. You have to know that. So let's just try to see. This is the electrochemical series. The way you see, we are having cations and also we are having anions. These are cations and this is the volts, the electrical potential values. So it is like this, the electrochemical series. As we go down, and these are the anion. The anions, they are like this. So here we're having the most readily discharged and we're having the least easily discharged. So that means when we're having silver ion is the cation which will be mostly readily discharged. When we're talking about the anion side, it is hydroxide ions which will be at the bottom of the series, which will be readily discharged or most readily discharged. And remember this point, we are told not, except for solutions containing copper, that's number one, silver, number two, and mercury. The products at the cathode is usually hydrogen gas. But we are told not unless the solution is highly concentrated. So that means here in this factor we are talking about the position. That means what we are talking about will be dilute solutions. Okay, what do we mean by this point? We mean, for example, if we are talking about dilute sodium chloride solution, when we're talking about dilute sodium chloride solution, it contains 4 ions in total. 2 ions are from the ionic compound, that is sodium ion and also chloride ions, and the other ones are from water, that's hydrogen ions and also hydroxide ions. So we talk about, first of all, the one that we are going to have at the cathode. At the cathode, we are having sodium ion and also hydrogen ions. So we go to the electrochemical series, we are going to see the position of sodium and the position of hydrogen in the electrochemical series. So that means sodium is up here, then hydrogen is somewhere here, down here. So that means what we are saying is the one that's always below, the one that's down, the one that's always the bottom of the series is the one that will be preferentially discharged. So here that means between sodium ion and hydrogen ions are below sodium in the electrochemical series, therefore they are the ones that are preferentially discharged. And remember, the other thing that we can know is that we are talking about cations. Cations, we said they are in the side of reduction, because when we're talking about cations, they will be getting attracted towards the cathode, and cathode is the electrode where reduction occurs, and reduction is gain of electrons. When we're talking about gain of electrons, we talk about tendency. This is not negative, it's just 0.00 volts. We are talking about the tendency of gaining electrons. So sodium is more negative. That means it has a high tendency of losing rather than gaining. But when we're talking about hydrogen, it's having 0.00. So it has the highest tendency of gaining electron compared to sodium ions. So when we're talking about the other side, chloride ions and hydroxide ions, we are going to take again the electrochemical series. That means hydroxide ion is the one that's at the bottom, then chloride ions are somewhere there. So that means always the ones that are below are the ones that are discharged. So hydroxide ions are preferentially discharged over chloride ions because we are going to say they have high tendency of losing electrons compared to chloride ions, because they are anions, and anions they move or gets attracted towards the anode, and anode is the electrode where oxidation occurs, and oxidation is loss of electrons. So the ones that are having high tendency are the ones that will be the high tendency of losing electrons, are the ones that will be discharged at the anode, and the ones that are having the highest tendency of gaining electrons are the ones to be preferentially discharged at the cathode. So let's come back to this point now. This point here, we said not, except for the solutions containing copper. So here, when we're talking about sodium chloride, dilute sodium chloride, we said the cation that we have there are sodium ions and also hydrogen ions. So what you're supposed to check is only, do you have copper? If yes, hydrogen will not be discharged. Check, do you have silver? If yes, hydrogen will not be discharged. Do you have mercury? If yes, hydrogen will not be discharged. So if you don't have any of these three, that means hydrogen will be discharged. So check here, we're having sodium ion. We don't have copper ion, we don't have silver ion, we don't have mercury ion. That means hydrogen will be preferentially discharged at the cathode, and it will be reduced to hydrogen gas. That's why hydrogen gas will be formed at the cathode, unless the solution is highly concentrated. We say this is dilute sodium chloride. If the solution we are talking about is concentrated, that's another thing. We are not talking about that case. So we are going to proceed. So we go to examples. Example 1 or example A, we are told electrolysis of dilute sodium chloride using graphite electrodes. So remember, we said graphite electrodes, they are inert electrodes. They are inert electrodes. That means they will not react with the products formed at the electrodes. So I say sodium chloride solution contains sodium ions and chloride ions from sodium chloride, hydrogen ions and hydroxyl ions from water. So in total we have 4 ions: sodium ions and chloride ions from the ionic sodium chloride, hydrogen ions and also hydroxide ions from the water. So when we check again, we have 2 cations and 2 anions. So we're going to say, when an electric current is passed through the solution, that's dilute sodium chloride solution, we're told chloride ions and hydroxide ions, being negatively charged anions, they migrate to the anode. They will move towards the anode. Because they are negatively charged anions, they will be migrating towards the positive terminal. That's the anode, the positive terminal of the battery. So we are saying hydroxide ions are preferentially discharged as they have high tendency to lose electron compared to the chloride ions. So next we are supposed to look for the reaction at the anode. So we are having 4 hydroxide ions aqueous losing 4 electrons to form 2 moles of water and also 1 mole of oxygen gas. So learners, remember this equation. This equation is very simple, because always when we are talking about dilute solutions, always if you are using inert electrodes, always we are going to form, or we are going to discharge hydroxide ions at the anode, and the equations becomes like this. So you have to know it even overhead how to write it. 4 moles of hydroxide ions losing electrons to form 2 moles of water liquid, 1 moles of oxygen gas, and 4 electrons lost are written on the product side. So we're going to go next. We are saying sodium ions and hydrogen ions, being both charged cations, migrates to the cathode. That means they are both charged cations, they will be migrating towards the negative terminal. That's the cathode, the negative terminal of the battery. Then between sodium ions and hydrogen ions, which one are we preferentially discharged? We are told hydrogen ions are preferentially discharged as they have high tendency to accept or to gain electrons compared to sodium ions. So we have seen this in the electrochemical series. If we go back to the electrochemical series, this is how it is. When you check sodium ion, it is here. When we talk about hydrogen ion, it is here. And we said always the one that's the bottom will be the one that's most readily discharged. So hydrogen will be discharged over sodium. One of the reasons we can say, because it has, hydrogen has high tendency of gaining electrons compared to sodium ions, or you can say because hydrogen is below sodium in the electrochemical series. That's the reason that you can give. the reaction that's going to take place at the cathode. So at the cathode, the ion is just there as hydrogen ion, then it will be accepting the 4 electron loss from the anode, this 4 electrons loss from the anode, to form 2 moles of hydrogen gas. So we are going to see observations made. The observations made at the anode are having bubbles of colorless gas that lights a glowing split is formed. So that means when we talk about anode, this is the anode, we have formed oxygen gas. So that means we are going to see observation of bubbles of a colorless gas that lights a glowing split is formed. So at the cathode, when we check cathode, we are having hydrogen gas. So we are seeing bubbles of colorless gas that extinguishes a burning splint with a bob sound is formed. That's the formation of hydrogen gas. So next we are going to see the electrolytic cell. This is how the electrolytic cell look like. This is the electrolyte. The electrolyte is here. This is the electrolyte. And the electrolyte that we have is solution of dilute sodium chloride. Then we're having the electrodes. One is the cathode electrode and the anode electrode. So this is after electrolysis. Check, we are going to get hydrogen gas and also oxygen gas. Remember, when we are having oxygen gas, the electrode there is anode. Don't forget that anode is where oxygen is formed and cathode is where hydrogen gas is formed. Okay, we are going to see bonds to note. We can see 2 bonds. One, we are told the volume of hydrogen produced is twice the volume of oxygen produced. We can see that in 2 ways. The first way, using the electrolytic cell, it is here. When you check oxygen, it is times 2 of the volume. Just check the space of hydrogen. Or what you can do is you can check the ionic equations for the reaction taking place at the cathode and that of the anode. We say this is the cathode, this is the anode. So the mole here is 1 mole of oxygen gas, but here the mole of hydrogen is 2 mole. So that means the volume of hydrogen gas produced is twice that of oxygen. We move the second point. We talk about the concentration of the electrolyte, that is the dilute sodium chloride. The concentration of the dilute sodium chloride solution increases. The solution becomes more concentrated. Why? This is due to the removal of water from the electrolyte. Or we can say due to the decrease in the amount of water because the volumes of hydrogen and oxygen liberated are in the same ratio as they are in water. That's the other reason that we can give. So learners, that's the end of our class today. Thank you for watching.